Hello. Tonight our lesson is on writing algebraic expressions, part 2. So go ahead and draw the pictures of these two squares. These should look very familiar. We did these during class when we were working in our teams, and you should recognize that the first one is a 10 by 10 square, where this is Tina's method for counting, and what Tina did was count the top and bottom as 10, but then she subtracted 2 from the sides so that the corners don't get double counted. And so she wrote the sides as 8 and then added them together. Now in your teams, after you looked at that, you were then given an 18 by 18 and asked to use Tina's method to figure out how many tiles there would be. Well, using her method, the top and bottom would have the full amount, 18, but then the two sides, you would take away the corners and get 16 and add them all up. So the total amount of tiles for the first one was 36, and for the second one was 68. Okay, so go ahead and draw this on your notes. Here is a generic or a general way of showing Tina's rule or method for any size square. So you can see that her method, whatever the size of the square sides are, then top and bottom would be that number. Okay, so in the first square when x was 10, then the top and bottom were 10. And then the second square, the lengths of each side was 18, so top and bottom was 18. So here, by putting x at the top and bottom, that tells us whatever the size of the square is, whatever the lengths of those sides are, that's what you would put for the top and bottom. Okay, now think about what she did for the two sides, how she took away the two corners. So if x is the length of the top and the bottom, then what would be the lengths of the two sides? Again, this is a general statement or a general expression for any size square. So think about it. What would you do with the value of x to get the length of each side? Well, you would take away 2, right, for the corners. So that means whatever x is, then x minus 2 would be the lengths of the two sides. And if you go back and look at the previous slide, that's what happened. When x was 10, then the top and bottom was 10, and the two sides were 10 minus 2, or 8. When x was 18, the top and bottom was 18, the two sides were 16. All right, so we can write this as an expression by just adding up all the sides. So if I have x plus x is the top and bottom, plus x minus 2, plus x minus 2, this would then give me an algebraic expression for a square of any size. And I could figure out how many tiles there are. Now, of course, this expression is not simplified. We can simplify this expression by combining the numbers and the terms together. So, for instance, instead of writing x plus x plus x plus x, I can combine those all together. How many x's are there? Well, that's right, there are 4. So I can just write that as 4x. And then I have minus 2 and minus 2. Well, what is minus 2 more? That's right, it's minus 4. So the expression 4x minus 4 I can use to calculate the number of tiles in any size square. If that's 100 by 100 square, then 4 times 100 minus 4 would give me the total amount of tiles, 396. Okay, go ahead and draw this on your paper. Perhaps you recognize it. This is one of the methods that we could use. It's different from Tina's method to calculate the number of squares or tiles in any size square. Okay? So, for this one, let's use x to represent the length of the sides of the square. All right, so think about it. If x is the length of each side of this square, okay, from here to here is x, from here to here is x, all the way around. Okay, what is this method showing? How is this person counting the tiles? What are they doing? Are they including the entire row on the bottom? Look at the red. Are they including the entire row? No, they're not. How many tiles are they taking away? If you said 1, you're correct. What they're doing is they're taking the value of x and they're taking away 1, and they're calling it the length of that side. And they're doing that for all 4 sides, right? They're going x minus 1. For the blue, they're taking away 1. That's x minus 1. For the side shaded in black, whatever x is, they're taking away 1. And then for the side that's unshaded, they're also taking away 1. So each side is x subtract 1, and then you can add those up, or to make it even faster, you could just multiply. You can go 4 times x minus 1. And if I added up all these sides and wrote them out, x minus 1 plus x minus 1 plus x minus 1 plus x minus 1, that's a really long way of writing it, but look what happens. 1, 2, 3, I have 4 x's again, and I have minus 1, minus 1, minus 1, minus 1. Look at that. I come out with the exact same expression as the last method, 4x minus 4. So you see, it didn't really matter how we broke up the square into its different pieces. When we simplify it and write it as an algebraic expression, we still come out with the same answer, the same general rule. Okay, which of these expressions are equivalent to each other? Take a good look. There are 4 of them. Combine numbers and x's together if you can in each one, and then compare them. Okay, the first expression, there are 2 x's. And 1 plus 1, so that's 2. So this one and this one, those are the same. 2x plus 1, no, that's not the same. And this is x squared, that's x times x, not x plus x. So that wouldn't be the same either. So those 2 were the same. Remember, read some books.